start, what are the basic steps involved in the machine learning process, and that the base we have to build with a simple you can say definition, the using data to answer the question. So here you can see two parts is there in definition. We have to use the data and we have to answer some question. Like the question is simple as that see whatever input data we are giving, so that particular data belongs to which particular class. Using data means it is a training phase. Whatever data is available with us, that we are using for the training of our model. Okay, and answering question means it is a testing or the prediction phase. And once we have defined a model or trained a model over the existing data, and so either new data we can apply to answer the new questions. And so training phase and testing phase. Okay, now the workflow of ML is like this. Initially we have data. Okay, and this data we are using for the training purpose, through which we will get the model. Okay, and we will apply the new data or the test set data over that model to answer the new questions. So this is very basic flow. Data we have to take, we have to train the model, and once our model is trained, we can apply the new data to answer the questions according to the new data. Okay, so see, these are the 7 basic steps that we have to learn whenever we are applying the machine learning to any field. It may be the mechanical engineering field or the computer science field or the electronics or any field. And so these basic steps remain the same. So first one is the data collection, second is feature extraction, then data pre-processing is required. Okay, after that we have to choose a specific model or a specific algorithm for development of machine learning model. Then we have to train that model, test that model, and after the testing, if we are not getting the desired result or good accuracy, so we have to do the parameter tuning, because initially we can assume some, you can say, predefined parameters values are there, so that means we will go with that. But if we are not getting the desired output or high accuracy, so then this parameter tuning is also required. Okay, so one by one we will explore these steps. Okay. So your first step, that is the data collection step. In that step, you can say it is the very beginning of the machine learning model, because see, if you are not having the good set of data or the values, so we are not able to train our model in a good manner. So see, first we have to decide that what to observe or record as per the need of the problem. Okay, say like you want to build a model for prediction or the classification of the you can say some information about the car or a vehicle. Okay, so generally means we have to model in a manner, say like we want to predict the say mileage of any car. Okay, so we have to think in a manner, the mileage of any car or a vehicle is dependent to what factors, like the weight of the vehicles, okay, number of the wheels, okay, and your the power generated by the engine. So these are the several factor or the parameter that we have to observe from the various vehicles or from the various cars. Okay, so according to that we have to collect the data. Okay, so first we have to analyze what data will be helpful for solving our problem. Then in how many number of classes we have to classify that data. Then after this, number of instance or sample means how many samples we are collecting. Okay, because Your training is also dependent to the number of samples available. If you are not having so much varieties of the data or the class, your model will be not easily trained. Okay, and then what type of data you are collecting, and your data is in the image format or in the signal format or in the text format. And so these things we have to predefine before the data collection. If these we have defined, so we can easily collect the required data. And once we have done with the data collection, so we have to do the feature extraction process. But this feature extraction process nowadays not in the trend. Why? Because mostly nowadays people are developing the model from the deep learning kind of techniques, and in that we are not doing this feature extraction part. Directly we are giving the raw data to our model, and it will extract the feature and do the classification or prediction. But see, as we are learning the fundamentals of machine learning, so this we have to know that what is the feature extraction part. So basically it is related to the reduction the dimension of the data. Okay. So only see some we are converting our raw data into some meaningful information that is of very small dimension. So what is the benefit? It will speed up the training time of the model, and also in a small space, or the memory requirement of your to save the training data is also less. So see, time domain feature, frequency domain feature, and many other statistical method are there by which we can easily do the feature extraction. It is just for converting data to the lower dimension and extracting some meaningful information. Now the third step is data pre-processing. Okay, so see, actually what happens, these first three steps, okay, means after the data collection you can apply the data pre-processing also, and because you have to analyze the data, and say while recording, if say your sensor is not properly working, or your recording device is not properly working, so you may get the some wrong values or null values during the recording. So you have to also deal with that, how to handle with these null values. So multiple methods are available, because see, nowadays people are using the Python or MATLAB for the implementation, in which already predefined method is there, that what we have to do with the null values. Because what happens if you are directly eliminate the null values, so it will reduce the you can say size of your data. So rather than deleting that particular value, you can simply assign some average value or the mean value of other sample. And so this is the very common method, but multiple methods are also available to deal with the null values. Then you can also apply some noise removal method. Okay, some filters are there, like you are recording the signal or images and they are not of good quality. Okay, so you may apply some filter also, so their quality will increase, so your model will easily train on that data. Because if noise is there, so again the training phase is not correct, and you are not end up with the good model. And after that, in data pre-processing, you can also do the visualization of the data to see the relation between the variables. Okay, so what is the advantage of this? Say you have recorded say 7 variables or 7 attributes from the corresponding to any problem, and once means before giving that data to the model, and if you are able to identify the relation between these variables, so you can easily eliminate some of the variables. Why? Because say if the same is information is available in more than 2 attributes, and so it is of no use. So we can eliminate one of the attribute, and you can simply check the correlation or the coherence between the variable. So if they are having almost same kind of information, so one we can eliminate. The other problem that we have to handle in data pre-processing is the data imbalance. Say if you are doing the classification task, and in that particular class, say we are taking just the example of 2 class classification. Okay, so say in one class, say you are having the 100 number of samples, which are belonging to class 1, and in class 2, say you are just having the 50 samples. Okay, so it is kind of, say, data imbalance problem. Okay, so it will means if you will directly supply this data to the model, so again your model will not run perfectly, and it will be little biased toward the more means class in which we are having the more sample, and because this task the model is repeated more number of time as compared to the other class. Okay, so how to handle this? Again, so much varieties of methods are available. Okay, like the resampling method is there. What we can do, we can randomly repeat the sample in this second class, and we can simply create copies of data points that we already have to make the 100 number of samples. Okay, the other sample is that we can randomly generate the new samples within the mean and standard deviation of this second class. Okay, so several means method are there how to balance the class samples. So if in both the classes we are having the same number of samples, so that is the balanced data. Okay, one more thing is there, but I will not suggest that thing to do, that we can simply eliminate the 50 samples from the class 1. But if you are doing this, so you are simply reducing the size of the database, but it is not the good option. Say if you are having the samples in lakhs and 2 lakhs, then it is good that you can simply eliminate the extra samples. But say if you are already having the less number of sample, so you have to go with the new sample generation, or that we can also call as the synthetic samples or artificial samples. And the last step in data pre-processing is that we have to split the data into train and test split. Okay, because see, in machine learning, say total we are having 200 samples. Okay, in say 200 samples in class 1 and in class 2. So what we have to do, we have to make a train set, and generally we can take it from range between 75% to 80%. Okay, and we have to create a test set also, so it may vary according to this 25 to 20%. Okay. So say if from the 200, okay, so say this become your 40 and this become 160. So 160 samples we are keeping for the training purpose and 40 samples we are keeping for the testing purpose. Okay, so during the training we have to use only these 160 samples. Okay, so this we have to also define. And nowadays this validation set is also getting famous, because you have also read in several papers they are applying the n-fold cross validation, 10-fold cross validation, 3-fold cross validation. So they are talking about this validation set also. So training set is there, validation is there, and at last test set is also there. Okay, so this validation test set is nothing, and generally we have to take like this only, means this part is only your 160 sample and this is only 40. And what is the use of this validation set? Basically the use of validation set is when to stop the training, and in training process simply we are taking samples one by one and we are training our model. So generally what happens, we will get a trend like this, your graph, and if we are making the graph, okay, so say here we can write iterations, okay, and here see if we are plotting the error, so as the iteration of training will increase, your error goes downward, है ना. So it is normal phenomena. But what happens sometime if your training error getting almost to 0. So it is a type of overfitting problem, and means when you apply the test set, so your model is not able to classify in a good manner. Okay, so at that time what we have to do, we have to use this validation set also. So basically validation, the use of validation set is that, say out of this, and again we are taking say 100 sample for training and here 60 sample for validation. Okay, so training we have to do over these 100 sample one by one we have to take, and say we are defining that after every 10 samples we have to take one sample from the validation set. Okay, and this just we are doing type of testing within the training phase. Okay, so see, like this is this first line is for the training error. Okay, and say this second line is for the validation. Okay, so say initially both will drop down. Okay, so we have to keep going on training. Okay, and once your validation error will start increasing, so at that point we have to stop the training. Okay, because see your training graph says that error is further decreasing, but validation graph is saying that now after this particular point your error will increase, and so at this particular point we have to stop. And so this is the use of this validation set. And so whatever is the weight or the status of model that we have to save, and it will give the good result over the test set also. Okay, now after that, in fourth step, we have to choose that which particular model or algorithm we have to use for building the machine learning model. So say like multiple options are there: regression, logistic regression, support vector machine, that we have already seen. So according to our compatibility, or the requirement of data, we have to choose these algorithms. And the most famous one is the artificial neural network. Okay, and nowadays many people are applying convolutional neural network also. Okay, and your support vector machine and the decision trees, and these are old traditional machine learning algorithms. Okay, now fifth one is the training phase. Okay, so see this a very simple example I am taking. Say like our problem is the prediction of y from x, and x we have already seen is a type of input and y is the output. Okay, so generally say if something like this we have to do, and this is the x, okay, and this is the y that we have to predict. Okay, and say these are few sample in our data that we have. Okay, so we can simply model this problem of your y is equal to fx, this particular line. Okay, so this line equation of line we already know, and y is equal to mx plus c. So it is nothing but y is equal to mx plus c, and simply we are using this b notation in place of c. So where m is the slope and b is the intercept, or that we can call as a bias in the terms of machine learning. Okay, so see if multiple m will be there as per the number of features, so collectively we can call as a w. Okay, so this w representation you will see in almost all the machine learning algorithm, and because say for each of the variable different this slope is there. Okay, it is just a simple case, only one feature we are considering or one input we are considering, so we can easily model with it with the line. And or say some non-linear trend is there, so we can also use the non-linear regression type of thing. And it means we can do the curve fitting type of thing also. Okay, so this W is there and this V is there in almost all the models. Okay, so this W and V, this we have to remember. Okay, so bias is there and weights of model is there. Your machine learning algorithm is nothing but is about how to get the correct value of W and V with this training data, and either we are fitting it with line and or we are fitting it with curve. Okay, and for multi-dimensional problem where we are having the x1, x2, x3 like these attribute, so line is converted into plane, then plane is converted into the again multimodal spaces. Okay, so accordingly that we have to manage, but the ultimate goal of any machine learning algorithm is to identify set of weight and a bias. Okay, so now this is the training process flow, and step by step we will see. So see, initially we will have the training data. This training data we are applying over the model, and initially this model is blank, means initially the value of W and V is 0. Okay, initially the model is a type of empty or totally is not having any learning, and it is new. Okay, so initialization is done with 0 values. Okay, now we will get some prediction, and because in empty model we are giving the input, so we already know that we will get some wrong output, but that model is predicting something. Okay, and this prediction we have to compare with the actual output. So here we can say this X we are giving input to the model, and this we can call as a empty F. Okay, it is doing some prediction that we can write as a P. Okay, and this is our Y. Okay, compare with actual output. Okay, so on the basis of this, we can simply write your Y minus P. Okay, so or we can write P minus Y. So this is your error. Because we already know that for the first time model is untrained, so whatever input we are giving, it will give the wrong prediction. So there is some error. So with the help of this particular error, we will get some guidance and we have to update the weight accordingly. Okay, so this is the main thing in any machine learning algorithm, that how we are utilizing the error. Okay, to update the and say this time, and according to the algorithm, the rules are different from algorithm to algorithm. So say we are taking the W is equal to 0, and it is just an example, and we are updating the value W is equal to 0.0 and we are updating V is equal to 1. And these are just randomly I am writing, and whatever is the rule of your algorithm, according to algorithm we have to update this. Okay, and after this we have to take the next sample from the database, and same process again we have to repeat. So sample by sample, and now see for the next iteration, these values become this, your W become 0.01 and your B become 1. And so now something we have to something is there in the model, and some learning is there in the model. So means iteration by iteration we have to repeat these all 4 steps. So slowly your error is going down, and you will get the less error in further coming iterations. Okay, so this is called the training flow or the training process, and the complete execution of all these steps is, you can say, it is the one iteration of your training phase. Okay, your error calculation, weight updation. Okay, these are the 2 main things that you have to do in one iteration of the training phase. And at the last, testing. Okay, so we have to apply the new data to get the new prediction or the classification, and that data is unseen data to model. And because what happens if we are giving the data that is same as the training, so means automatically you will get the good result, because the data is already seen by the model, and it is simply you can correlate with say we are the faculty, and we are teaching some problems in the class, so easily a student can easily understand them, and if same problem we are giving in the exam also, so student will get the good marks, and so it is the same thing, and so generally we have to give the new problems to the student in the exams, so testing phase is the same, means in the examination of the model we are giving the new data. Parameter tuning, say after doing all this, if you are not getting the good accuracy, means your model is not properly trained, so reason is that either you have to provide the more training to the model, and so number of epochs, and what is this epoch? Your epoch is nothing but it is equal to training iteration of all samples. Say I will take one example, say 100 samples are there. Okay. So to process these 100 sample, we need 100 iteration, and that is called the one epoch. Okay. So the complete you can say tracing of the training samples, iteration by iteration, it is called the one epoch. So if you are doing the two epoch training, means you have executed 200 iteration, and once you will done with the 1 to 100 samples, again you have to start from 1 to 100, and again you have to start from 1 to 100. Okay, means same data you are giving again and again to the model, and so you may increase the epoch to better train the model, and you can also modify the learning rate. Now what is this learning rate? Say in the updation of weight we have seen, and we are giving some new value to W. Okay, so this learning rate is nothing generally denoted as the alpha in many of the algorithm, and so we have to say if we are taking 0.001, okay, so it is low learning rate, and if we are putting the alpha is equal to say 0.1, and so it is the high learning rate. It is just a ratio in which we are updating the value of y. Okay, so if we are taking high learning rate, and so your model will train faster, and like this means more step side we are taking, and so learning rate we can increase or decrease based on the performance. Okay, and out of these two, each and every algorithm may have its own parameters also, and like if we will talk about the artificial neural network, so number of layers, okay, then activation function is there in the neural network, so how to define the activation function, and so several parameters are associated with each of the algorithm, so that we have to also change. Okay, so this parameter tuning is, you can say, one of the important step, and that you can increase the accuracy or the prediction with the help of these parameters.